Hello friends, welcome back to my channel Chemistry with DB. So in this video I am going to compare the basicity of ammonia and different types of amine, which is primary, secondary, tertiary, and the phenylamine, which is an aromatic amine. So we'll start with looking at the structure of this ammonia. So ammonia, here nitrogen is bonded to 3 delta positive hydrogen atoms, and there is a lone pair of electron because nitrogen was in group 5. So all of these 5 electrons are shown here now. In case of a primary amine, methylamine, nitrogen is bonded to 2 hydrogens and 1 alkyl group, which is the methyl group here. In case of a tertiary amine, secondary amine, nitrogen here you can see is bonded to 2 alkyl groups and 1 hydrogen, which is why it's called a secondary amine, because nitrogen is bonded to 2 carbons here. In case of a phenylamine, which is an aromatic amine, the nitrogen is bonded to 2 hydrogens here and 1 aromatic benzene ring. Now let's start with comparing the basicity of ammonia and primary amines. So as we have just seen that in case of ammonia, nitrogen is bonded to 3 delta positive hydrogen atoms and lone pair. So the lone pair is what is making it accepting proton. So this lone pair can be used by this nitrogen to form a dative covalent bond with an H+. In case of a primary amine, we can see that instead of 1 hydrogen, now nitrogen has got 2 hydrogen and 1 carbon, which is in a methyl group. So that alkyl groups, these are electron pushing. And in other words, we call that alkyl groups have a positive inductive effect, means they push electrons towards this nitrogen. As a result of this, the lone pair is becoming more available to gain a proton more easily. So now no such positive inductive effect was there in case of ammonia. So therefore we can see that ammonia is not as basic as a primary amine. Now when we compare a primary and secondary amine, now in case of primary amine there was 1 alkyl group here, which was causing the positive inductive effect, pushing electrons towards nitrogen. However, in case of a secondary amine, there are 2 alkyl groups and both of these are pushing electrons towards this nitrogen. As a result, the lone pair is becoming even more available than the primary amine to gain a proton. Therefore, we can easily see that primary amines would be less basic than a secondary amine. Now, let's also look into a tertiary amine. So, we might argue that tertiary amines have got 3 alkyl groups pushing electrons towards nitrogen. So therefore there is a much greater positive inductive effect as compared to primary or secondary. But you can see that there is no hydrogen bonded to nitrogen here. No hydrogen bonding means this tertiary amine would be very little soluble in water, and that less solubility causes it to be less basic than a secondary amine. Now let's look into the basicity of phenylamine. Now in case of phenylamine, nitrogen is bonded to 2 hydrogens and a benzene ring, and benzene rings are electron withdrawing. So therefore what benzene ring does is that it withdraws electrons away from this nitrogen, or we can say that there is a negative inductive effect here. Now the negative inductive effect caused due to the aromatic ring. So as a result of this, the lone pair of electron is becoming part of the ring. It is delocalized into the benzene ring. As a result, it is much less available to gain a proton. So this is why we can clearly see that phenylamines would be the least basic, because they are much less likely to be able to accept a proton easily. So now, after looking into all of the arguments, we can come to the conclusion and we can rank these in order of their increasing basicity. So the least basic is phenylamine, followed by ammonia, then primary amine. After that comes tertiary amine because it's less soluble than the secondary amine, and secondary amines take the trophy of being the most basic. So I hope this you were able to understand through my explanation. And if you like this video, then please like, share, and subscribe. And I look forward to seeing you in my next video. Bye bye. Take care.